Hello everyone. Today we're looking at another Leetcode problem. This is 3085 minimum deletion to make a string case special. You're given of a string of characters called word and an integer value called k. A word is case special if the frequency difference between two consecutive indexes is lesser than or equal to k. And a word might not be case special by default, so we have the opportunity to delete few characters, and the question is expecting us to return minimum number of characters that we need to delete in order to make the word case special. Okay, so before we proceed with this solution, let us just ideate on this a little bit. So if we have bunch of repeating numbers, let's say A, and B, and then C, and then a few more B's, and then let's say D. Okay, if there was no constraint of minimum, and maybe if we wanted to have like a maximum number of characters to delete, if there was something like that, then what we could have done is we could have found the lowest frequency character, which can be 1, 2, whatever it may be, but whatever is the lowest frequency, and then adjusted all of the other frequencies based on that. So we can look at this, right? So A has a frequency of 3, so you subtract from 3, you subtract the minimum frequency. Likewise, B has 4, you subtract 1, you get 3, here you get 2. These are the number of deletions because we are keeping only one of these characters and deleting these many, so we will keep summing. This will be the total number of deletions that we make in order to uh, keep all of them in the same frequency. But the problem is slightly different than this, right? First of all, we are not looking to get the same frequency. We are looking to get the frequency in the range of k. So let's say if there is a particular frequency, the capacity that we have is frequency plus k. So what this means, like how do you identify the frequency, which is like your base frequency, and you adjust all of the other frequencies to match to your base frequency. So adjustment is quite straightforward. The problem is all about identifying what is the base or the target frequency that you should have, such that you get minimum number of deletions. Okay, so let's look at it with some examples, right? Let's say, let's consider some examples. Let's say this is example 1. Okay, so you have A, B, and C. Okay, here if I delete the min frequency, then I can get both of them of the same frequency. And let's say k is either 0 or 1, then we are looking to get something like this. But here, if I keep C, this is B is of frequency 3, C is of frequency 1. So if I look at the difference between the frequencies of two consecutive indexes, I get 2, which is greater than what my K might be. So here, deleting the lowest frequency is actually a good thing. Let's look at another example 2. And let's say I have 4 A's, 2 B's, let's say 2 C's, and maybe 2 D's as well. So each of these have frequencies of 2, but this has frequency of 4. And if I want to stabilize this, then I probably need to delete one A because that will give me 3, 2, 2, and this is like a minimum deletion that I have to do. In order for me to now, if I delete A, I get just one deletion. But if I want to preserve, so here what I'm doing is I'm deleting from the maximum frequency. If I want to delete from the minimum frequency like I did before, then I would be ending up deleting 6 characters, and so I will not prefer this. So from these examples, it's quite obvious that it's not very straightforward which frequency we should be using. It all depends upon the setting of the problem. So what this means is that we will have to explore the frequencies, and we will have to try out the different frequencies, and we'll have to see which one gives us the minimum number of deletions. Okay, what that means is, if we take the example from the problem, which was a b c b a and k is equal to 0. So when we take the count of this, we get a is equal to 4, b is equal to 2, and c is equal to 1. Okay, and so let's say I have 4, 2, 1 in this order, and maybe, or even in some other order. It doesn't matter, because in this problem we are not looking at the absolute variations of the string, what the different variations are going to be the valid ones. We are only looking at the number of deletions that we need to work out. So we can work at a high level like this with the frequencies. Okay, so what I'm going to do is I'm going to assume that this is my target frequency, which means I want to keep this as my target frequency, which means that all of the other indices have to fall in the range of this. Okay, what does that mean? So what that means is, if 4 is my target frequency, I have 2 possibilities. Okay, one possibility is I have the character frequency which is less than 4, which means I can never make that character reach a frequency of 4. Okay, in that case, I will just delete this character. Okay, other possibility is this character frequency is greater than 4. If it is greater than 4, there is a possibility that, so what I was saying is that there is a possibility that my character frequency is within this range. Very good. Or my character frequency is beyond this range, which means this is the extra delta that I want to remove, so such that I can have that formula where I have the frequency of word of I minus frequency of word of j, this thing fall within my k range. Okay, now you might be wondering, why are we deleting a character if it is lesser than my target value, and why are we doing this check only for the greater side of things? Because the formula says that on either side we are looking for a delta difference, then a word can be lesser than 4, but within the k delta, or sorry, a frequency can be lesser than 4, but within the delta range, delta of k, and a frequency can be also greater than 4 and also be within the delta range of k. Then why are we only looking at the greater sign and not the lesser side? Well, the answer to that is quite straightforward. What we are trying to do here is we are trying to create ranges. Okay, and there are 2 ways you can create these ranges, and both of them will work. Okay, so let's say if your target frequency is t, okay, you can create your range as t frequency minus k till t frequency, or you can create your range as t frequency to t frequency plus k. Okay, both of these are valid because all you care about is creating these fixed ranges and seeing how many of them fall within that k range, and how many you will have to delete. So that is all about this problem. So if we have to convert this into pseudocode, what we will do is, first of all, I will use the fmin, fmax, lambda function optimization, which is a slight optimization over using min and max, because min and max have little bit of an overhead in Python because they accept variable arguments, either a list or two arguments. So let's use this. F min is equal to lambda x comma y returns x if x is lesser than y, else y. Same way, f max is a lambda function of x and y, returns x if x is greater than y, else y. Okay, now let's also import from collections, import counter with a capital C. Okay, so let's collect the counts here and say counter of word. Okay, and then just take the values. So it's going to be a list of some numbers. That's all we care about. Okay, and then say the best delete count is equal to 1e9. We want to minimize this. Okay, so we start with the very last number. Then what we say is for target frequency. So for each value, one by one, we're taking an iteration. Second time is this, third time is this. Okay, so for each iteration, the target frequency in ch counts is taken, and then we're going to compare it with the same list again. Okay, so we're going to compare it and we're going to say, where does this break? Wherever it breaks, we either delete part of it or all of it. Okay, and depends. So let's see. So we say our del count, which is a temporary variable, starts with 0. Okay, so you say for curve frequency in ch counts. Okay, now what you're going to say is the del count is equal to, okay, curve frequency if curve frequency is lesser than my target frequency. Remember, we said we are taking the range of t frequency to tf plus k. Okay, if it is lesser than this, it is not in this range, so I will have to delete this. And it is not lesser, but it is greater. If it is greater, then we are looking at where is it. Okay, how many deletes do we need to make? If it is well within this range, I need 0 deletes. If it is greater, then I need to take the delta. So let's write that part. Okay, so what we are going to say is this curve frequency is lesser than this range, then this is going to become 0. So this is going to become negative. So let's handle that as returning 0 deletions. So this is our code, and all we need to do is keep adding this at the end. Let's just quickly check for the best del count, which maybe make this as f max, and then let's take f min of existing del count, comma current del count. Okay, when this happens, finally you can just return the best del count. That's about it for this problem. It is a little confusing, but if you work out few examples and think through this, it will start to settle in. Alright, that's about it for this problem. See you next time.